In this video, we are going to talk about perpendicular lines, and we're going to start with an investigation. So our first question says, for the lines shown, and they are over here, it says, are these lines parallel, perpendicular, or neither? So when we did the parallel part, we said parallel lines are evenly spaced and do not cross. Perpendicular lines meet at 90 degrees. And if it's neither, it means the lines cross, but they don't cross at 90 degrees. So looking at these two lines, they do cross. The question is, do they cross at 90 degrees? So I have a protractor here, and I am just going to see if we can measure that angle. And I see that our angle goes from 0 to 90, so they are 90 degrees. Sorry, there's a little bit of glare there. If you don't have a protractor, then you can use anything that's square to check. So I often will use the corner of my ruler, right, to see if that makes 90 degrees. Or sometimes your eraser might be rectangular, or you might have a Post-it note or something that is square that you can use to just check that that's 90 degrees. Okay, so these are perpendicular. They do meet at 90 degrees. Okay. So similar to our investigation on parallel lines, it asks us to state the y-intercept and the slope for both line 1 and line 2. Like last time, we will do line 1 together. You will try line 1 on your own, and then we will see what we notice. So looking at the y-intercept for line 1. So this one is line 1. My y-intercept is 5. So my b is 5. And then for the slope, I'm trying to look at how we're getting from one point to the next. So I noticed between 2 points, we were going 2 squares up and 3 squares over. Since we're going up, that's a +2, and if we're going to the right, that's +3. So my slope is going to be 2 over 3. Okay, I'm going to ask you to take a moment and see if you can figure out line 2. Pause the video if you need to. I'm going to try to work it out and see if we can maybe take the same amount of time. So calculate your y-intercept and slope for that second line, please. Okay, hopefully you either paused the video or you had enough time to do it. I found that the y-intercept was -2, so it crosses the line at -2. And my slope, I noticed between the points we were going down 3, and then we were going to the right 2, so it's -3 over 2. So I ended up with a slope of -3 over 2. Now for the comparison part, did they have the same y-intercept? No, they did not. So they had different y-intercepts. So they have different y-intercepts. And when I look at the slope, I also notice they don't have the same slope. But there definitely is a connection between the two slopes. They use the same numbers. So this one here we have 2 over 3, and this one here we have 3 over 2. So they have the same numbers, they're just upside down. There's a name for that. It's called a reciprocal, right? And I also notice that they have different signs. Line 1 was increasing. It had a positive slope and was going up. Line 2 had a negative slope was decreasing and going down. So I'm going to put the fancy math words and then we'll write down underneath what that really means. So the slopes here are negative reciprocals. So negative reciprocals. So the negative part means they have different signs. So one is positive, one is negative. They have different signs. So the negative part means they have different signs. The reciprocal part means the fraction is flipped. Okay, so when you have two lines that are perpendicular, they do not necessarily have the same y-intercept. They could, but they don't usually. And their slopes are negative reciprocals. They have different signs. One's positive, one's negative, and they're going to be flipped versions of the fraction. So I'm just going to fill that word in again. So lines that are perpendicular have slopes that are negative reciprocals. Which just means they have a different sign and the fraction is flipped. Okay, there are two questions here that follow up on that idea. So we're going to maybe do one together and you're going to try one on your own. So our first one says, determine whether each of the following pairs of lines are perpendicular and then state a reason for your choice. So we said to be perpendicular, their slopes need to be negative reciprocals. So I'm going to look at the slope of the first line, which is 4/5, and then the slope of the second line, which is negative 5/4. And I'm going to ask myself, do they have different signs? That's the negative part. And the answer is yes. One of them is negative, one of them is positive. And then the second part, are the fractions flipped? And the answer is yes, those fractions are flipped. So these are perpendicular. And then the reason depends what you want to write. You could say the slopes are negative reciprocals. That would be fine. You could say the slopes have different signs and the fractions are flipped. That also would be fine. But I'd like to write as little as possible, so I'm going to say the slopes are negative reciprocals. Okay, I'm going to give you a minute to take a look at B. I would like you to see if you think those lines are perpendicular or not, and then we'll take that up. So take a second and think about it. Okay, we're going to check in. So the first line has a slope of 1/2. The second line has a slope of negative 1/2. Do they have different signs? Yes. Are the fractions flipped? No. So these are not perpendicular. And my reason is the fractions are not flipped. So the fractions are not flipped. Okay, we do have one more question. This is question number 2. it says determine the equation of a line with a y-intercept of 3 that is perpendicular to each of the following lines. I think we're going to try doing B together, and then I'm going to have you do A on your own. So looking at this, if we're doing an equation is y equals mx plus b. And we want to fill numbers in for m and b. So looking at this, in the question, it told me it had a y-intercept of 3. That's the b. And then the m is going to need to come from this line. So this one is actually kind of tricky. So first of all, the slope is -1. That 1 was hiding. But not only was that -1 hiding, the number underneath it is also hiding. There is a very shy 1 underneath that. So this has a slope of -1/1. So when we go to do our perpendicular slope, we are going to take this and we are going to flip it over. So -1/1 is going to become 1 over -1. So my equation is going to be y equals 1 over -1, and then x, and then plus our y-intercept of 3. Now, I can divide 1 by -1. 1 divided by -1 is just -1. So I have y equals -1x plus 3. Either of those equations is fine. I don't mind. I am going to ask you, though, to take a moment and see if you can figure out what the equation is for number 2. Actually, not to interrupt, I realized I made a mistake. Did you realize that I made a mistake? So I said when they're perpendicular, they're negative reciprocals. So we need to change the sign and flip it over. I didn't change the sign. All I did was flip it over. So if I change the sign, we would make it positive, and then we would flip over the 1/1, and it would just be 1/1. So this should be a +1, not a -1. I'm sorry about that. Okay, so like I said, I'm going to give you a second to see if you can do this one. Okay, so for this one, I got y equals -5/2x plus 3. So you needed to change the sign, so I made it negative. And then the 2/5, I flipped it over to get 5/2x. And then I used the y-intercept that was given in the question, which was plus 3. Okay, there are some practice questions there for you to try on parallel and perpendicular lines.